Have you ever wondered how AI can solve complex problems, not just guess answers, but reason through them step by step? Today, we're diving into a breakthrough that's redefining how large language models, LLMs, approach reasoning. Mixture of reasoning, or MoR. This research isn't just about smarter AI. It's about teaching machines to think like humans, with adaptability, strategy, and scale. Let's unpack how it works and why it matters. At its core, MoR tackles a fundamental limitation of traditional LLMs: their reliance on manual prompts. Think of prompts as instructions, like asking a student to think step by step before solving a math problem. But these prompts are static. Designing them for every task is time-consuming and inefficient. MoR flips the script. Instead of humans crafting prompts, the model learns to generate its own reasoning strategies. It's like giving a student a library of problem-solving techniques, rather than dictating every step. So how does MoR actually work? The process has two key phases. First, thought generation. Researchers use powerful models like GPT-4o to create reasoning templates, blueprints for solving problems. These aren't one-size-fits-all. They include strategies for multi-step deductions, analogical reasoning, and even creative leaps. For example, one template might break a math problem into smaller parts, while another uses metaphors to reframe a challenge. Next comes supervised fine-tuning, SFT dataset construction. Here, those templates are paired with real-world data. Imagine taking a math problem, a history question, and a coding challenge, then mixing them with the reasoning blueprints. The AI learns to select the right strategy for each task, like a detective choosing tools for a case. This training allows MoR to adapt dynamically, without relying on pre-written prompts. Let's look at a concrete example. Consider this scenario. Isabela, a baker, takes a bag from the pantry labeled sugar, but later realizes it's flour and puts it back. The question, does she believe the bag contains sugar or flour? A baseline model like QN2, 5-7b, might assume she still thinks it's sugar, missing the key detail that she changed her mind. But MoR 150, the best-performing model, analyzes the problem step by step. It recognizes that her action, putting the bag back, indicates a shift in belief, flour not sugar. The result? A correct answer that aligns with human intuition. And the numbers back this up. On benchmarks like BigTom, which tests theory of mind and trivial creative writing, a mix of storytelling and trivia, MoR outperformed traditional methods by 13.5%. That's not just incremental improvement, it's a leap. For instance, on BigTom, MoR 150 achieved 73% accuracy, a significant jump from the baseline. Even simpler approaches like input-output I/O sometimes outperformed chain-of-thought (COTI) on straightforward tasks, proving that flexibility matters. What does this mean for AI's future? MoR isn't just about beating benchmarks. It's about creating systems that can handle real-world complexity. Think of tasks requiring nuanced reasoning, diagnosing medical conditions, drafting legal arguments, or even writing a novel. MoR's approach makes AI more reliable, versatile, and human-like in its problem-solving. It's not just about answers, it's about how the AI arrives at them. So what's next? This research opens the door to AI that doesn't just follow prompts, but adapts to them. Imagine models that switch between logic, analogy, and deduction on the fly, like a genius with a library of tricks. The implications are huge, from personalized education to autonomous systems that reason through ambiguity. The next time you interact with an AI, remember, it's not just spitting out answers. It's learning to think, adapt, and solve, like a student with a toolkit for the unknown. Thanks for watching. If you want to explore how MoR compares to other methods or see real examples, check the links below. Stay curious and keep questioning how AI is reshaping the future. Ever wondered how AI models really think? Like, do they just guess answers or actually reason through problems? Today, we're diving into a fascinating study that's changing how we understand AI reasoning. Let's break down what researchers discovered about how language models tackle complex tasks and why it matters for the future of artificial intelligence. The study tested AI models on two key challenges: BigTom, a benchmark for theory of mind, the human ability to infer others' beliefs, and trivial creative writing, which asks models to craft stories while embedding trivia answers. Researchers compared three approaches. 1. Chain-of-thought (COTI), prompting models to think step by step. 2. Input-output I/O, a direct just-give-me-the-answer method. 3. Mixture of reasoning, MoR, a new method where models mix reasoning strategies dynamically. Take the Isabela example again. A baseline model might assume she still thinks the bag is sugar, but MoR 150 recognized her action, putting it back, as a sign of updated belief. This isn't just accuracy, it's a deeper understanding of context. The results? MoR models outperformed traditional methods, especially on complex tasks. On BigTom, MoR 150 hit 73% accuracy, a 13.5% boost over the baseline. Even I/O, which seems simpler, sometimes beat COTI on straightforward tasks. It's like having a toolbox where the right tool matters most. What does this mean for AI? MoR shows models can adapt their reasoning, making them smarter and more versatile. This isn't just about benchmarks, it's about real-world applications. From solving puzzles to understanding human emotions, MoR is a step toward AI that thinks, not just computes. So the next time you interact with an AI, remember, it's not just spitting out answers. It's learning to think, adapt, and solve, like a student with a toolkit for the unknown. Thanks for watching. Stay curious.